Let me welcome you to the 58th lecture of NPTEL online certification course Drilling and Blasting Technology. In this lecture, we will discuss environmental impact of blasting, but as we do in each lecture, before continuing to that, let us retrospect so far what we have covered. So far we have covered basics drilling and blasting technology. We know what is explosive, what are the explosive properties, how explosives interact with rock and rock mass to disfragment the rock. Then we know how to design the blast for a surface blasting, bench blasting case or for underground blasting case where only single free face is available. After that, we have discussed the different blasting results, that powder factor, rock fragmentation. We have solved a number of numericals related to blast performance, related to the drilling and blasting costing, and we have discussed the impact of rock and rock mass properties on blasting results and special blasting techniques. We also know the numerical methods of simulate blasting problems. So, that is also known to us prior to carrying out the exact blasting that we have covered in the just previous class. In this lecture, we will cover the environmental impact of blasting. Basically, the environmental impact of blasting considered in terms of generation of dust or particulate matters, generation of noxious gases, because blasting is a chemical which interacts and generate gases under along with release of high temperature and heat and shock. So, that is why the huge quantity of gases are basically generated. So, what are the impact of those gases? Their health effects and how to analyze them and to what are the precautions to be taken. So, apart from that, actually blasting is generating ground vibration and noise also, but we have already covered ground vibration and noise in our previous lectures as the blasting results. Okay. We have already covered, we have seen how to control the ground vibration, what are the impact of ground vibration on the structures, how the noise is basically annoying the nearby inhabitants and the local species of fauna, etc. So, those are basically discussed. So, in this lecture we are not going to discuss on those ground vibration and noise. We will consider environmental impact of blasting, only dust and noxious gases or toxic gases like NO2, SO2, NOCO, etc., CO2, etc., we will discuss. So, other things are not discussed for this particular lecture. Now, these are the safety hazards we have already discussed, and we are not going into discuss of this fly rock and ground vibration problem. Let us look into one blasting video. We will try to understand a number of things in this. So, you can see there are a number of holes already drilled in this bench and the blasting has to be carried out. Now, let us see it is open for the blasting. So, we are going to blast this face. This is one YouTube video we have taken. So, you will see when this blasting is being see. Now, this blasting is carried out and you see on the blasting huge quantity of dust you can see. Okay. So, this dust now we can see, let me pause it. Now, you can see this yellow film. Okay. This yellow film is basically coming out, this is basically the oxide of nitrogen. So, this oxide of nitrogen has come out because this is generated. So, that is why I have opted for this video, so that I can show you that this oxide, nitrogen oxide has come out by this blasting. So, apart from this CO2 and other nitrogen oxides, these oxides are also coming out, SO2 etc., and huge quantity of dust, that is the particulate, that is the fine fragmented particulate matter, that is also coming out. So, in this lecture we will basically understand those things, how this quantity of huge dust, huge quantity of gases, that is basically generated, and that is having, you can see this is dusts are basically propagating inside the mine and moving out of that. Now, let us understand what is particulate matter. Particulate matter basically the atmospheric aerosol particles, and that is suspended in the air, moving from one place to another place and pose some health risk also. There are different categorizations of the particulate matter, and those particulate matters poses health risk, some are not posing health risk. So, most of the cases this particulate matter enters through our nose, and we may have throat irritations, we may have choking in the lungs, bronchitis, that may goes into the asthma, etc. So, those things are the problem. If the poisonings are there like lead, cadmium, silica, we may be diagnosed with silicosis, pneumoconiosis, all these diseases are possible. So, if you see in overall aspects, the blasting carried out, that creates the problem, which reduce the visibility temporarily in that area. That may, if the sulfur is there, that may deposit H2SO4 droplets, etc. It may damage soils, aquatic life of the water bodies. In fact, the generation of the dust can move up to a huge longer distance, because these dusts are generating almost a plume condition. So, that may travel a long distance and may create other problems. So, before going into these details, let us discuss once what is particulate matter and what is dust. There is this particulate matter and dust, these two terms are very similar and often used as interchangeable way in some situations, but not in others. We can consider particulate matter and dust are same, but that is not true for all conditions. So, that is a little bit clumsy one. In fact, particulate matter is defined very specifically. It is a mixture of solid particles and liquid droplets found in the air, as the definition is given by the United States Environmental Pollution Agency, EPA given definition is there. However, there is no clear definition for the dust. So, it is very problematic one, but one is that all particulate matters are dust, but it is not that all dusts are particulate matter. So, that is the difference basically. So, dust consists of particle of all sizes. Similarly, you can define the particulate matter also, but these droplet conditions are not associated with the dust, but that may be associated, may not be associated with the, whether it is there or not, but all particulate matters are considered as the dust, but not the dusts, all dusts are considered as the particulate matter. So, this dust definition is very ambiguous. So, it is not properly defined, some are good, both are same, some are good, it is not same. Invariably particulate matters are basically classified in inhalable particles, that is PM10, and fine inhalable particles, that is PM2.5. So, in PM10 consists of all the dusts which are below 10 micron size, equivalent diameter is below 10 micron size, and PM2 is fine inhalable particles which having the diameters below 2.5 micron. So, basically fine inhalable particle is also a subset of the inhalable particle, that is the PM10. So, PM2.5 is basically a subset of PM10, and dust is basically consisting of all the visible particulate matters. Now, if you consider it physically, basically human eye cannot detect any or consider any particles which is smaller than 40 micron. So, that means PM10 or naked eye or natural eye cannot detect, PM 2.5 cannot detect. So, whatever we are considering dust as the visible particle, all are above those particulate matter, that is we are considering the visible dust. There are invisible dusts also, which are basically considered those particulate matters which are not visible to us. And if we are considering our human hair, which is there in our hair in the head, so that is almost 70 micron size. So, basically in the next slide it will be very clear to you. If we are considering this part which is basically a hair, you can say this is the 50 to 70 micron size, and you can consider there are so many PM10 particles can combine themselves to make this size, and there are so many PM 2.5 also can combine, 4 PM 2.5 can combine to make one PM 10. So, that is the basically size range which we are considering as the particulate matter, and this is the physical understanding of those particulate matter. This slide is taken from this source, which basically, and 1 micron, you understand 1 micron means it is 10 to the power minus 6 meter. Now, let us understand that lung penetration of particles, basically coarser particles can go up to the upper respiratory tract, fine particles go much deeper, and if it is very fine, then it may come to our alveolus, ultra fine may go into our body or bloods also. So, these are the problems, but it is considered that all this particulate range that may lead to our pneumoconiosis disease, either it is a silicosis or coal minus pneumoconiosis or siderosis. These are the diseases generally occurred because of the choking of the lung from the dust particles or particulate matters. So, basically the coarser particles considered PM10, which is inhalable, but the coarser part, and fine particle is PM 2.5, may deposit in the deeper lung also, may generate mist in the atmosphere, fog, reduce the visibility. These are possible with this, and you can consider the ultra fine particles are also there that can come to our circulatory system also. Now, there may be other sources like say smoke, generation of waste, movement of the vehicles, exhaust of the diesel engines, etc. All are basically generating particulate matter, dust, whether it is ultra fine, fine or maybe inhalable. So, these are basically generated, and these are the sources. The sources can be classified, as the consistent source, maybe the temporary source, and these are the different classifications. The impact may be significantly high, impact may be significantly less, that is depending on the quantity which are being generated. So, this is one important part, and that must be considered when the discussion on the dust is basically carried out. Now, the dust is basically a pollutant, or particulate matter is basically a pollutant which basically travels a lot. The transportation occurs onto this pollutant through the air. So, that is the biggest problem with this particulate matter transportation. So, this transportation of the dust or particulate matter is called dispersion. The reason is that it is transportation is basically dragged by the movement of the air, and it is dragged by the natural way, because the concentration is high, it is moving out for reducing its concentration, and that is being assisted by the wind or velocity of the wind. So, it is depending on the wind, it is depending on the velocity of the wind, depending on the wind directions. There may be a crisscross wind directions, that is basically creating very complicated situation of the dispersion of the dust. However, while the dust modelings are basically considered, we basically considered the simplistic models. So, there are three common models available, one is called box model, one is Gaussian distribution model, another is Gaussian puff models. So, just let us look once into these models in a very simplistic way. So, box model is basically considered that it is a box under which the significant area is there. So, you can consider one city is inside a box, okay. And box is having 3 dimension, it is just like a box, parallelepiped type box, or you can say a cube type box, where there is 3 direction x, y and z. Obviously, z is a vertical direction, and x direction is considered as the direction in which the wind is flowing. So, the wind direction is considered as the x direction, and its transverse direction is considered as the y direction, and z direction is the vertical direction. So, this is the concept of the block model, where we consider the complete city is significantly coming into that box. Now, in this consider the L is considered for the wind direction, and the transverse direction is W is the width of the box in the transverse direction, and H is the height considered as the height above up to which the mixing is possible, above which no mixing is there. So, the total mixing of pollutants is up to height H, that is considered in the z directions, and it is considered the emission rate is constant. So, that means this model is applicable where constant emission is carried out, that means like chimney of a say thermal power plant or so. So, that is the considerations, but here the considerations is the source is at the floor level. So, that is the considerations carried out in this case, and the emission rate is constant unchanged with the time, and that is the steady state condition is considered. So, another assumption is made that the turbulence is strong enough in the upwind direction, that the pollutant concentration is uniform in the whole volume of the air over the city, and not higher at downwind side than the upwind side. So, this is the conditions which is made. So, wind blow in x direction, velocity is constant, that is with the time velocity is not changing, and the elevation above the ground it is not changing. So, that is the considerations. The concentration of the pollutant entering into the city is constant and is equal to the background condition, that means the before the pollution what is the state, that is the equal to the same, and air pollution rate is considered is the q gram per second or milligram per second, whatever is that one, and is given the emission rate is given per area, and conversion can be made, q small q is equal to q into A, that is the area, is W into L, that is the surface area of the box, and no pollutant enters or leaves through the top of the top and side. So, whatever is there it is in the ground surface only. So, that is the, and the pollutants are not decaying, that is the another assumption is made. So, based of this model's assumption, the steady state concentration is expressed in terms of C is equal to q L into U H, where L is the distance over which the emission takes place, and q is the area emission rate, h is the mixing height and u is the wind velocity, that is the considerations of the box model. So, however, the drawback of the box model is that here the constant emission is considered, and that is why it is not very suitable for the blasting purposes. Similarly, Gaussian plume model is basically the most popular model in the dust dispersion considerations. Here we consider a stack height of h s is there and the wind is flowing in one direction, that is considered as the x direction, and height is z direction, and mixing is allowed over the height, that is coming down is also allowed. Reflection is also allowed from the dust, considered it is not mixing with the ground, it is again moving up to the atmosphere again. So, in that considerations, the one is the main source is basically polluting, another is the imaginary source, that is reflection of the ground is considered here, and considering this the model is come out where the effective pollution is coming here from the stack, and this is from the imaginary source, that is the reflected ground condition. This is the movement through the transverse directions because of the plume stack plume is expanding in the volume. So, these considerations are made is in the Gaussian plume, and by this way the concentration at any point x, y, z is basically calculated in this case. There is another model which is basically these are the drawbacks, these are very common environmental problems is known to you. So, these are not being discussed here. Another model is called Gaussian pop model. This model is very much resemble to the blasting case, where we are considering these puffs, that emissions are made in terms of puffs. So, just like a steam engine it is considered, the steam engine is just emitting the puffs, the same way the puffs are coming out, and we believe that blasting problem is more or less resembled with this puff condition, and that is why for blasting emission considerations this puff model is considered as the better model, and this puff model is expressed in terms of this formula, where this puff is basically similar to that, it is actually the expansion is considered in terms of x direction, in terms of y direction, in terms of z direction. These are the concentration that dispersion coefficients which are considered here, and the wind velocity is considered in this particular case, because the x direction is the wind velocity direction. So, this is the considerations made for the Gaussian puff models, which can be popularly used for the dust dispersion for the dust generated from the mining. Now, this is one part of dust, we understand the role of the PM particulate matter sizes on the environmental effect. However, blasting is momentarily generating the dust and not pose a significant problem, because the quantity may be a little bit higher, concentration is little bit higher, but the exposure time is very limited. So, the dust basically dust pollution on the human health depending on basically two things, one is the dust concentration and second one is the exposure to that dust concentration. In blasting problem, though the dust concentration is high, but the exposure is very limited, it may be for few minutes, even if it may not be for 10-15 minutes, it may be for few minutes, 1 minute or 2 minutes, something like. So, that is why the exposure duration is very less, and during that exposure limit it is very easier for people to have sufficient protective measure, and that is why it is strongly believed that dust is not creating a significant problem, or particulate matter generated from the blasting is not very significant health risk for the workers and the nearby inhabitants. However, the other noxious gases are generated from the blasting, that is mostly because of the reactions occurs. So, most of the cases our explosives are having nitrates, nitrogen oxides are there. On reaction it is generating the nitrogen oxides, carbons are there, carbon oxides, and hydrogen is there, hydrogen oxides. So, however, hydrogen oxide pose green as the it is a greenhouse gas, it creates some global warming etc. problem, but hydrogen oxide, that H2O does not have any health risk. However, if carbon particle is there and because of the improper oxygen balance, it is not converted into the carbon dioxide, it generates carbon monoxide. If carbon monoxide is there, that is really a lethal gas, it creates problem, it is odorless, colorless gas, toxic gas, and by inhalation of that it is creating carboxyhemoglobin, which is very difficult one, very poisoning one, and creates a problem. So, it is always believed that we should give sufficient oxygen for the explosive in terms of the oxidizer, not oxygen means it is oxygen gas, we must give the sufficient oxidizer, so that the generation of carbon monoxide must be avoided. However, generation of the nitrogen oxides is very difficult. We have seen in the video, that is a reddish orange brown gas has come out, which is nitrogen dioxide. Basically nitrogen dioxide generation, it is a toxic highly corrosive gas, can be converted into the nitric acid when it is coming with the water, and it is having lung irritations, for long time it may create asthma. So, that is why this is having some health risk, but one important part is that we generally ask our blasting engineer to view the color of the blast fume. The nitrogen dioxide generation means we have given excess oxygen to the explosive. The excess oxygen is basically result into nitrogen dioxide, that is why that yellowish brown gas is generated. And this excess oxygen, that reaction is not giving us the oxygen balance reaction. Oxygen balance reaction must give us the maximum energy generation. So, basically we are losing some energy by generating that nitrogen dioxide, and that is why that must be avoided. We should reduce the quantity of oxidizer, that is the ammonium nitrate quantity must be reduced, so that the generation of nitrogen dioxide should be controlled. Okay. So, that is the requirement. However, nitrogen dioxide is having some health risk. Often if the explosives are having sulfur, that also generates sulfur dioxide, and the sulfur dioxide is also a colorless gas with irritating some odor, and with mixing with water it generates H2SO4, which is acidic. So, this nitrogen dioxide and sulfur dioxide, these two in atmosphere mix with the water and give the acid form, and that come out with the rain when the raining occurs. So, that is the problem generated in the environment. Otherwise, exposure to this are very for limited time. So, that is why only for few minutes this irritating irritations because of the NO2 SO2 may occur to the nearby inhabitants and the working personals. So, this is more or less about the environmental impact of blasting in terms of dust and fumes, blast fumes. We will as the final topic we will discuss the standard operating procedure and safe working principles in the next few lectures. Thank you.